get started, you should have your science notebook, scissors, glue, and these notes. We're doing a Venn diagram today, light and sound, sound and light. Okay, when you cut them out, remember we're going to cut out around the outside edge, and then we're going to cut the 2 vertical lines. We're not going to cut out the actual Venn diagram. Okay? So that we're going to get a Venn diagram flip-flap. Go ahead and cut that out. And then we're going to look at page 34. Or whatever page you are on. For me, it's 34. Sound versus light. And then our Venn diagram is actually going to fit sideways on this page. Excuse me. Emily and Allison. You have a question?
Yeah, so the shadows from last week, when are we going to do that?
Uh-huh. The which one?
The shadows?
Shadows, we did not do. We went over it. We drew on the activity page. We just never put it in our notebook because I am trusting that you understand how shadows work. Which is when the light is on, say, the right side, what side will the shadow be on?
So do we need it?
No, you do not. All right, sound versus light. And then what we're going to do is we're actually going to talk about some of the similarities here because there's really only 3 similarities between the 2, okay? Light is, of course, an EM wave. That's what we talked about yesterday. What was sound that we talked about from yesterday? Grace?
A mechanical wave?
Yeah. And there's only so many similarities between an EM wave and a mechanical wave. Okay? What's one of the differences? Or I'm sorry, one of the similarities between an EM wave and a mechanical wave? This one's really obvious.
I know.
Okay, what is it?
They're both waves?
Correct. They are both waves. So if they're both waves, then they can both do something. What do they do? What are waves? What's the purpose of a wave?
They can both go through stuff.
Okay, so they can travel through a medium. Clayton, what are some things that are a medium? When we talk about a medium, what are we talking about here? What is a medium?
Liquid, gas.
Great job. Liquid, gas, or a solid. And then there's one more similarity, and this has to do with them being waves. And that is because waves can carry what? What do they carry?
Energy?
Energy. Great job, Tyler. At least I think that was Tyler.
It was.
Perfect. And then, as Furman said, they are both really helpful. They are both very helpful to us. one of the questions when you talked earlier when we were talking about types of waves or the differences between EM and mechanical waves, one of your questions was, are waves important to us? Explain how they're important to survival. And you guys usually picked either light or sound and explained why those things were important. So, of course, there is that. Okay. And then from here, we're going to talk about the differences. We are going to talk about the differences between them. Okay. So one of the differences we wrote right on the top of the Venn diagram is that light is an EM wave, sound is a mechanical wave. So if we look at light here, light as a electromagnetic wave has very specific properties, very specific things that it can do. Okay? What are, my little sun, I'm going to draw suns for bullet points. What are some things that electromagnetic waves do that mechanical waves cannot do?
Light waves can also travel through a vacuum.
Yes, great job. Light waves can travel through a vacuum. Or through space. Which is why we get light from the sun on Earth. And why I'm drawing suns for my bullet points. Okay. Now, how do we think about how we graph light waves? Think about what a light wave graph looks like. Okay? How is that different?
Maggie, no.
How is that different from a sound wave? What type of wave does an electromagnetic wave look like? Thinking like transverse or longitudinal? Is it parallel? Is it perpendicular? What do light waves look like? How about we try transverse waves? Does that sound right? Light waves look like a transverse wave. Bailey, did you have something to add?
Yes. Light waves travel faster.
Yes, they do. Excellent point. Okay, so light waves travel at the speed of the universe. Okay, they are the fastest. And then there's one last point, one last thing that you guys learned, but you might not think is all that important, but it is very important. Is a very important difference between these two waves. And it is that energy, the amount of energy in the wave, is determined by, does anybody remember how you can figure out how much energy is in a light wave?
Amplitude?
Amplitude is a great guess. That is actually sound.
Optics.
Sound.
Frequency.
Yes, it's frequency. Energy is determined by frequency. Energy is determined by frequency. And then we're going to take Skylar's very good guess, and we're just going to make that our first bullet point for sound. Because that is one of the differences between the two. And it's that energy in a light wave is frequency. So if it has a high frequency, it has high energy. In a sound wave, if it has high amplitude, it has high energy. Scooch it. Let's talk about sound. Of course, is a mechanical wave. That is some inherent difference between an electromagnetic and a mechanical wave. Okay. Oh wait, no, that's a star. I want to do a speaker. Okay. So, sound waves. We're going to take Skylar's very good guess. One of the differences between light and sound is that the energy is determined by amplitude. The energy is determined by the amplitude. What's another difference between light and sound?
We can travel at the speed of sound.
It can travel at the speed of sound, and is that faster or slower than light?
Speed of sound is a lot slower.
Yes, so it
Speed of
is.
light.
Go ahead, keep going.
Yeah, the speed of light is 900,000 times faster than the speed of light. Speed of
Yes.
sound.
Yes. Yes. So it is significantly, 900 is a lot, significantly slower than light. Okay. And you guys have experienced this phenomena. You might have even talked about it with little brothers, little sisters, mom, dad, grandma, grandpa, whoever. When you're in a thunderstorm and you see the lightning, and then it's a couple of seconds before you hear the boom.
The boom.
And there's the old adage, there's the old saying, that if you can count so many seconds between it, that's how many miles away it is. And there's some truth to that, and it's because light is so much faster than sound. So if you're really far away from a lightning strike, you're going to see it. It's going to take a good amount of time before the sound of all of that discharged energy reaches you. Okay, so it is significantly slower than light. Okay, what else is a difference between light and sound?
You can hear sound.
Yeah. Yeah. Noise. You can hear. My speakers are getting like bigger every time I draw them. Okay. Produces a noise you can hear. Evan says that we have like as a scientific community, can break the sound barrier, which is a fun fact. We absolutely can. We can travel faster than the speed of sound. But we have not yet been able to achieve faster than the speed of light, if it is at all possible.
Miss Derek,
Yes, sir?
wouldn't we have to like travel almost halfway across the world in 1 second to reach the speed of light.
Oh. You would have to have no mass to reach the speed of light. It wouldn't even be halfway around the world in 1 second. That's still far too slow. You have to think about like a photon is 0 mass, which means it's not made out of anything physical that we can perceive. It takes only 8 minutes, a little over 8 minutes, for light to leave the sun and make it to Earth. Okay, that's 8 minutes. And think about what the distance between them was. We're talking almost 100 million miles. It can travel 100 million miles in under 10 minutes. That's super, super fast. So to reach the speed of light, if it is at all possible, we have to figure out how to travel in a weightless state, in a massless state, which is quite the conundrum. Okay. Nathan also points out, or I'm sorry, Nathan is pointing out that one of the differences is that it cannot travel through a vacuum. Okay, it cannot travel through a vacuum. There is no sound in space because there is no substance in space. There's no medium for which, through which those waves can travel. And then there's one more. And this one, you guys might not, you probably don't know just by the nature, just by existing. A lot of these things about sound just because you have ears. Okay, or we've talked about them. And that is that sound is what kind of wave? Can you guess? If light looks like a transverse wave, what type of wave is sound? Bailey?
Longitudinal wave.
Yeah. Sound is a longitudinal wave. That's my best attempt at a longitudinal wave.
I have a question.
I have an answer.
Okay.